Solving rational equations. So we've looked at rational functions and we've looked at rational expressions, but what if we have rational expressions in an equation and we want to solve for a variable? So let's take a pretty simple example. We have 5/3 plus 5/6 equals x over 2. Now there's actually two ways we could do this. We could find a common denominator here and here, and then we could set the numerators equal to each other because we know anything over a common denominator equal to something else over a common denominator means those numerators have to be equal. The other way we could do it is we could multiply both sides by the common denominator. So we're sort of eliminating the fractions. The only thing we have to be sure of when we do this is to make sure we understand that there may be some excluded values. If some value of x would make that denominator 0. In this case, it wouldn't because we only have numerical values in there. We have no variables in the denominator. So I'm just going to take you through the procedure here and then we'll do some more complicated examples. So for our first one, our least common denominator is 6. So we're going to multiply our first fraction by 2 over 2 to get 6 in that denominator. This one doesn't need to be multiplied, already has that common denominator. And this one 3 over 3, I'm just essentially multiplying by 1. Then going ahead and distributing, I have 10 over 6 plus 5 over 6, that's my original, and 3x over 6. Doing that, I can see I have a common denominator. They're all 6's. So 10 plus 5 over 6 has got to equal 3 over 6. 10 plus 5 is 15. My numerator has to equal this numerator, equals 3x, and I can solve. X is equal to 5. And I can always go back up here and plug it in to make sure that that makes a true equation. Now let's look at the other method, multiplying by the least common denominator. So multiply this side by 6 and this side by 6. So it's a little bit different than finding that common denominator. I'm multiplying both sides by the same value. Multiplying by 6, I have to distribute that 6. This one I don't have more than one value. So I just have 6x over 2 on this side. This one I have 6 times 5 over 3 plus 6 times 5 over 6. Just distributing that 6 to both of these terms. So here I can find some 1's. 3 over 3 is 1 with a 2 left over, so I just have 2 times 5. My denominator has become a 1. Here, this 6 over 6 becomes a 1 and I just have 5. So 2 times 5 plus 5 is equal to, multiplying here, I have a 2 over 2 with a 3 left over, 3 for a factor, so just 3x. So then I can go ahead and multiply. 10 plus 5 equals 3x, 15 equals 3x, and 5 is equal to x. So it's essentially the same thing, it's just a little bit of a different procedure. Now let's look at some problems using this method. So say I have my variable r and I want to solve for r in these different fractions. Well, I have r in the numerator and in the denominator. R plus 2 over 2r plus 1 is equal to r over 3 plus 3 over 4r plus 2. Well, first I need to find the least common denominator, and to do that I factor. So this one's it's not factorable anymore. This one I can factor out of 2. So I go ahead and do that. And I want to look at my excluded values because I'm going to use the process of multiplying both sides of this equation by the least common denominator. So in looking at this, I can set 2r plus 1 is equal to 0. This one's not going to ever give me a 0 in the denominator, and this one will be the same as this because 2 is not a 0, so this factor is the only one that could give me a 0. Solving for r, 2r equals -1, and r is equal to -1/2. Therefore, if I get a value of r that's equal to -1/2, I'll know it's an excluded value, and I'll have to take it away from my solution set. So my least common denominator here, I need to have a 2 times a 2r plus 1, and also 3. So what I'm missing, what my total least common denominator is, 6 from the 2 and the 3 times 2r plus 1. And I'm going to multiply both sides of my equation by that. So my first one, I have 6 times 2r plus 1 times my first rational expression, and this one I'm just going to distribute both to this term and to this term. So I have 6 times 2r plus 1 times r over 3 plus 6 times the quantity 2r plus 1 times 3 over 2 times the quantity 2r plus 1. And now I can go ahead and simplify as much as I can. I see I have a 1 here where I have a 2r plus 1 over 2r plus 1. And so that will make a 1. And I just have a 6 times r plus 2. And that's equal to, I have a 3, and then I can take a factor of 3 out of 6, so I just have a 2 left. 2 times r plus 1 times r. And I can put that r and the 2 together for multiplying. And then I have plus, I have 2 times 2r plus 1. Here's a 1 here, and I can make a 1 out of the factors of 6, and I can take the 2, make a 1 here, and just have a 3. So I just have 3 times 3 left. Now, distributing, I can distribute the 6r plus 12 equals, and then I'm going to distribute the 2 and the r together. So 2r times 2r is 2r squared. 2r times 1 is just 2r. And then plus 9. So I have an equation now. It's a quadratic equation, and I want to solve that. In order to solve a quadratic equation, one of the easier ways to do it is to use the zero product property. So I'm going to go ahead and set it equal to 0 by subtracting 6r and 12 from this side of the equation, so I get a 0. So I have a total of 4r squared, and then subtracting that 6r from both sides, minus 4r, and subtracting 12 minus 3 equals 0. Now I can use the zero product property rule if I can factor it. So factoring this factors to 2r plus 1 times 2r minus 3 equal to 0. Setting both of those equal to 0, and I get a value of r equals negative 1/2 and r equals 3/2. Well, I know r cannot be negative 1/2, so I have to exclude that value. So r is equal to 3/2. Now I could take that 3/2 and plug it back in here to check to make sure that that's a true equation. If I were to plug in the negative 1/2, I would get a 0 in that denominator and recognize that that must be an excluded value. Looking at another one, we have x over the quantity x squared minus 1 plus 2 over the quantity x plus 1 equals 1 plus 1 over the quantity 2x minus 2. Now right away I can tell that x cannot be equal to negative 1 in either this case or this case, but it's easier to see if we put it in factored form. So factoring, I have x plus 1, x minus 1, and then here doesn't factor. Don't need to factor anything here, and factoring out a greatest common factor of 2 here. So I can see that negative 1 is going to make this denominator 0, and positive 1 is going to make this and this denominator 0. And so I know that x can't have the values of 1 or negative 1, and I need to keep that in mind when I'm finding my solutions. So multiplying by the least common denominator, the least common denominator here is going to include both of these factors. This one's already included, and a 2. So it's going to be 2 times x plus 1 times x minus 1. That's my least common denominator. Multiplying this side and this side, but distributing my least common denominator here too. I have this right here plus my least common denominator times my second fraction right here, my second rational expression, is equal to this times 1 plus this, my least common denominator, times this rational expression. And then I can go ahead and simplify it. So I have an x minus 1 and an x plus 1 over an x minus 1 and an x plus 1. That makes a huge one. And so I just have a 2x left. Plus x minus 1 over x minus, or x plus 1 over x plus 1. It's going to give me a 1. And I just have a 2 times a 2 and then this x minus 1 left. And that's equal to, I just have this times a 1, so that's just my least common denominator. And I put that into, I went ahead and distributed and got an x squared minus 1 because I know I'm going to have to distribute that too. So I just rewrote that in its distributed form. Plus 2x minus 1 and 2x minus 1 make a 1, and I just have x plus 1. Okay, simplifying even more, I have 2x plus, and then I went ahead and multiplied this to 4 and distributed. So 4x minus 4 equals 2x squared minus 2 plus x plus 1. Combining like terms and setting them equal to 0, I have 2x squared minus 5x plus 3, factoring 2x minus 3 times x minus 1, and that's equal to 0. So I know both of this one or this one could be equal to 0 and make this equation true. So I have x is equal to 3/2 and x is equal to 1. Well, I need to recognize that x cannot be equal to 1, either here or here. Otherwise, I would have a 0 in the denominator. So I need to exclude this value from my solution set, and I just have x is equal to 3/2. And again, I could substitute that back in to check to see if that equation is true. It's a little more complicated with the calculations, but you could definitely calculate it with your calculator. We could even use the decimal 1.5. Now let's look at inequalities. Inequalities are a little bit different. So if we had the fraction x minus 2 over x is less than x minus 4 over x minus 6, well, if they were just numbers, you would know what to do. The problem is sometimes if you're multiplying by a value that has a variable, you don't know if it's negative or positive. If it's negative, you're going to have to switch this sign. So you don't really know whether this is positive or negative. So one of the strategies mathematicians use is take away that part of it. Instead of multiplying by a least common denominator, you can actually just look at these as fractions. So you can subtract this fraction from both sides. That way we're not multiplying by a negative and we don't have to switch that sign. So subtracting this rational expression from both sides, I have x minus 2 over x minus, and this should be the quantity, x minus 4 over x minus 6. Now, looking at my excluded values again, I know x cannot be 0 and x cannot be 6. Those values will make that 0 in the denominator. So now I can find my least common denominator, but instead of multiplying everything by it, I can go ahead and find a common denominator and then subtract, or add in this case. Because I'm going to rewrite this subtraction problem like I did when I was adding rational expressions into an addition problem. So I made this is just plus a negative of this, and then distributing the negative. So I have plus negative x plus 4 over x minus 6. My common denominator is going to be x times x minus 6. So this rational expression is going to need an x, so x over x, in order to have that common denominator. This one's going to need an x minus 6, so x minus 6 over x minus 6, just multiplying by a fancy one. And then doing that, I now have a common denominator, x times x minus 6. I can go ahead and distribute this, and I get this expression right here. So I have x squared minus 2x minus 6x plus 12. And right here I do the same thing, distribute this x minus x squared plus 4x, and that's all over my common denominator. Well, simplifying this up a little bit, I get over here, combining like terms, the x squareds cancel. We have a positive x squared and a negative x squared, that gives me a 0. And I have negative 4x plus 12 over this. Well, this will simplify even more, factoring out a negative 4. So negative 4 times x minus 3, because when I distribute that, I have to get back to that positive 12, and that has to be less than 0. Now here's where the mathematical thinking comes into play. I know that this has to be less than 0, which means this must be negative. If this is positive, it's not true. And so I can look at certain values and check to see when that's negative. Well, really the only places things are going to start to switch signs is here at 3. So I know at 3 this whole thing is 0, and I want to know what's going to happen if x is negative or if x is more positive than 3. And so I want to look at this term, so I want to look right around 3. Same thing here. The only places where that's going to switch signs, go from positive to negative, is at 0. And here too, when x equals 6. On one side of the 6 it will be either positive or negative, and on the other side of the 6. So these are all called critical values, and it's where the denominator isn't defined or when the numerator is equal to 0. So my critical values that I really want to check are x equals 3, x equals 0, and x equals 6. Now I know x can't actually be equal to 0 or be equal to 6, or in this case be equal to 3, because that would be an equals 0. But I'm going to plot them because that's where my sign changes are going to occur. This is called a sign analysis. So I'm just looking at my values of x on a number line, and I'm looking at what happens around 0, 3, and 6. So before 0, after 0, before 3, after 3, and before 6 and after 6. So when I look at this, I can actually test values in here. So I can test values that are less than 0, negative values. Well, I know I'm always multiplying. Let's see, x less than 0. I know this negative 4 is always going to be negative because it's a negative 4. But then looking at this factor right here, this factor, if I have negative numbers less than 0, like a negative 5, this is also going to be negative. So I have a negative times a negative in my numerator. And that's over, well, if x is less than 0, this is going to be negative. And this also will be negative. A negative number minus 6 is going to also be negative. So my denominator is negative and negative. Now, since those are factors, when I multiply them, I can test the sign. Negative times negative is a positive, divided by that negative times negative, which is also a positive. So I know when x is less than 0, I have positive values here. And so that will not make this equation true, because this one must be negative. Then I want to try values between 0 and 3. So I can try like a 1. So in putting that into my equation, I want to look at values that are greater than 0 but less than 3. My negative 4 is always going to be negative. If I try a 1 here, this factor is also going to be negative. 1 minus negative 3 is negative 2. Over, x is going to be positive because it's going to be a 1. It's between 0 and 3. And x minus 6 is going to be negative. Then I can multiply those factors, at least the signs out. Negative times negative is a positive, divided by a negative, because positive times negative is a negative. So I have a positive divided by a negative, which is a negative. So it must be true here. This equation is true because this equation is negative between those values. Then looking at the values between 3 and 6, say like a 4. So values between 3 and 6, the negative 4 is going to always be negative, so that's the negative. And then 4 minus 3 is going to be positive number. And then over, this one will be positive, this one will still be negative. So then I have a negative in the numerator, negative times positive, and a negative in the denominator, positive times negative, and a negative over a negative gives me a positive. So this portion of my x values must be positive and not make this equation true. Remember, this equation has to be less than 0, has to be a negative number. So here, 6, let's look at our values there. X is greater than 6. So this one will always be negative. This will be positive. This will be positive, a 7 or a 10. That will be positive, and this one will also be positive. So I have a negative times a positive, which is a negative, over a positive number. That gives me a negative number. So therefore, these places are where this inequality, I guess I said equation before, but really should have said inequality. This inequality is true. This inequality is less than 0 when this is negative. And so it's between x between 0 and 3, and x after 6. So x is greater than 6. So you can write it like this. X is greater than 0 but less than 3, or x is greater than 6.